Solving a non-monic using the null factor law. Alright, there's a couple of skills that we've been missing here, and one is the null factor law. We're still not solving using that. The other is factorizing a non-monic binomial or quadratic. When you see solve, especially if they say using the null factor law, that should automatically tell you what steps you're going to use. If you have to solve, the aim is to find x. And since we're dealing with quadratics, we'll generally, often, have two different solutions for x. Your options, when they tell you to solve, are the null factor law, the quadratic formula, or completing the square. So, they want you to solve, we want to find x, these are our options. Here they've said use the null factor law, and in fact, if it's possible, you would use the null factor law because it's the easiest. So, to use the null factor law, we're not going to use these two. Your steps are that you must factorize the expression, or in this case an equation. The equation must equal 0, which this does. Then our null factor law comes into play, and I'll explain these steps once we've got to them. So our first problem is we've got to be able to factorize this, and I saw a lot of people, don't write this down, wrong. I saw a lot of people saying, oh well, this is 8 outside of x squared plus 2x minus 3. Sometimes they even put equals 0, which is very helpful, but none of this is correct. That 8 could only be taken out the front if it was a common factor of all three terms. When you factorize, so this was not a good thing, this does not work. When you factorize, so this is now just the steps for factorizing. Alright. You do look for and remove any common factor to all terms. So you would check, is there any number that goes evenly into 8, 2 and negative 3, and there's not. If we had 8, 12 and 6, then sure, we could work out that 2 goes into each of them, and we would divide each term by 2 and take that out the front. But there is no common factor here, so we can't change that. Now we recognize that it's a non-monic. So is it a monic or a non-monic? We tell by looking to see if a, the coefficient of x squared, is 1, i.e. it's not there, or it's another number. 1, it's not there, would be monic. Non-monic, yes. If it was a monic, then you just factorize it. So again, don't go writing this, but here's a nice little easy monic. And the method for that, remember, is you look for factors of C, factors of 2, that sum to B. So factors of 2 is 2 times 1, that's factors of C, and 2 plus 1, they sum to give me 3. And you would put those in your brackets, x plus 2, x plus 1, because those two are the numbers that go in the brackets. You've factorized a monic. But factorizing a non-monic, the steps are a little bit trickier. To factorize a non-monic, look for factors of AC. Not just factors of C, but factors of A times C, which sum or add to give B. And it's a good idea to do some working. So we'll go back to our question, and I'll write it again here. Keep the equals 0 in there. Don't go leaving that off while you factorize. It's part of your equation. You leave it there. Over somewhere else where you're not going to be in the way of your working, A times C is 8 times negative 3. It's negative 24. I want a pair of factors of negative 24 that would add to give me 2. So your factors of 24 are 24 and 1, 12 and 2. They've got to be about 2 apart. These are way too far apart. These will not help us. 3 and 8, getting closer. 4 and 6, there we go. We've found the ones that would add to give B, and before you say, well, 4 plus 6 is 10, remember one of them has to be negative, and which one's negative depends on what's happening here, because we're splitting up that into these two factors, and since it's positive here, the biggest one will be positive. So this is 8x squared. Now it doesn't matter what order you put these in, but you're going to write, instead of this, negative 4x plus 6x, or 6x minus 4x. Either way is fine. So we looked for those factors, and then we wrote this plus 2x as actually this was minus 4x plus 6x. Then, having done those two steps, the next step is factorized by grouping in pairs. That means factorize this pair, factorize this pair. The common factor here is 4x. 4x outside of 2x minus 1. The common factor here is 3, plus 3 outside of 2x minus 1. Don't forget your equals 0. These two will always end up, if you've done it the right way, the same. That comes out the front, 2x minus 1, because it's actually a common factor. We're factorizing out a whole bracket that's a common factor. What's left goes in, sorry about that, the second bracket. Don't forget your equals 0. Great. You've now factorized. The equation was already in the form of it equals 0, so we've done that. Now you have to use the null factor law. Whenever you've got a factorized expression which equals 0, this times this equals 0, which says either this or this must be 0, because the only way you can multiply something to get 0 is if one of those factors is 0. So for your null factor law, write each factor as possibly equaling 0. If there was a number out the front here, or a letter out the front like x, you'd say x equals 0, or 2 equals 0 if there's something out here. As it is, it's this, 2x minus 1 equals 0, or 4x plus 3 equals 0. Then solve for both versions of x. Solving this one, add 1 to each side, 2x equals 1, x equals 1 divided by 2, which is a half. Here, subtract 3 from both sides, 4x equals 3, x equals, divide both sides by 4, 3/4. You have solved. You have found two possible values of x. That was our aim, to find x. And we're going to say 1 or 2 values. Sometimes you can solve and there will be no solution. And this was using the null factor law. You factorize, your expression must be an equation that equals 0. So if they tell you to solve, you would, and it's only this part, you'd say let that equal 0. You factorize, you use your null factor law. You really need to be able to do this.